Hello everyone. In this video, we will be talking about pandas. As we have already discussed that panda is one of the most important package which can be used for data analysis. We can do any kind of data manipulation with the help of pandas. So I have created a pandas notebook with the name pandas, and we will see how we can use pandas in Python. Okay, so let's start. So before starting, this is the official website of Pandas, https pandas.pydata.org. You can navigate to this one and check what are you can read the documentation accordingly. Now, before starting with Pandas, the first thing is that we have to check that whether Pandas is installed in our environment, in our Anaconda environment or not. So most of the time, Anaconda provides the basic libraries like NumPy and Pandas. So we don't need to install it. But somehow, if we want to check that whether the pandas is installed in or not, then you can just type this command pip install pandas inside your Anaconda command prompt. Okay. So if it's already installed, it will say requirement already satisfied. If it is not installed, then it will install the pandas accordingly. Now, the next thing is once we have clarified that we are clear that pandas is already installed, then we can go ahead with importing the libraries. We are going to import pandas as PD. We are also importing here NumPy, but NumPy is not necessary here, but we will be using some small some part of NumPy code in this example. So that's why I've imported NumPy. So we can import the libraries, necessary libraries like this way. So we already know that pandas provide two types of data structure, support to two types of data structure. The first one is series, and the second one is data frame. So we will see how we can create a series. So before creating a series, we are going to create a list. So I've created a list with 5.4, 1.2, and these elements 5.6, 3.7, and 7.8. So these are the elements, and I've created a list. Similar way, I have created a array from this list using the NumPy. Now, the point here is that we can of creating a list and array is that we can create a series, pandas series from a list also as well as from an array also. So you can see here, I've created a series using list. So I've used the pandas series method and I passed the list which we have created. Similar way, if we are creating any series from array, so we can use the pd.series and we can pass my array. So this way we can see series from list. We are getting this list. Okay, so series is basically, you can say, a kind of a if you imagine an Excel sheet or if you imagine a CSV file, it's the one column. Series basically represent a single column of a CSV or an Excel file. Okay, so by default the indexes are provided here, like 0, 1, 2, 3, 4 for all the rows, okay, of a single column. By default, you can see these indexes as 1, 2, 3, 4. Okay, let me do one thing. Let me clear the output. Let me stop this one and cell a second kernel, restart and clear output. So I can run the code and I can show everyone. Yes. So now you can see there's only the code, no output. So I'm importing the library. So I'm doing control, I'm running it. Control enter you can do, and then I'm creating the list and array. Then series from list, this is the series from list, and this is the series from arrays. So basically it's a series. Okay, but the point here is that we can create a series from list as well as from array. Same way, if we want to find out the any particular element, so we can provide the indexing always start from 0. So if I want the 2, so we can provide the so 0, 1, 2. So you can see 5.0. So indexing of the rows always start from 0. So we can provide the index and you will get the necessary element. We can also add labels to the series. Now, when I say labels, like by default, the labels are like this 0, 1, 2, 3, 4. But if you want to give it a particular name, so you can do it by adding this index is equal to labels. So what will happen? Your series will now have index of your choice. First, second, third, fourth, fifth, and like this way. Then we do not need to be explicit about the entries of the period series. So you don't need to put like data is equal to my list or index is equal to labels. You can just provide my list and labels. It will automatically understand that, okay, you are talking about data and you are talking about the index. So this is how it's been created. We can also access the entries with the help of the index. Okay, so by default, the index were 0, 1, 2, 3, but we can also change the index. We have seen. So here, first, second, third, fourth, fifth. So these are the indexes for these elements. So if we want to find out the second, what is the value of the second index? So we can just put this one and we can run. So we get 1.2. Other thing is like we can perform the mathematical operations on series. So we know that this is our series, and if I want to do a kind of a concatenation, we know that doing concatenation, we use the plus operator. So let's see. So what we are doing here is we have created a series with these elements, first, third, fourth, fifth, and these are the values 5.5, 1.1, 8.8, and 1.6 respectively. So this series, which is named as my series, is being added to the series which we have already created earlier. So if we run this one, so we can see the two series is being added. We have done a kind of a concatenation. Now the next thing is, this was all about series. You can look into the series in detail, try to create your own series with different elements, try to create a series with a random number generated from 1 to 5 or 5 to 5. Like this way you can try it. Then we have data frames. Now basically data frame is a combination of series. As I told, series is just a one column. Just imagine series as a one column of an Excel file or a CSV file. But data frame is a kind of an Excel sheet. It's just like a kind of an SQL table which has rows and columns. So we can create a data frame by combining series, by combining the different columns, and we can create a series. So we can do that by using the concat method. Okay, we just run this one and see we have created this. Data frame. Okay, so by default, we already know that this here we have provided in my series that our index should be like this way: first, third, fourth, fifth, sixth. Okay, but if you don't provide the labels, by default it will be 0, 1, 2, 3, 4, and the column names will be 0, 1. Okay, then we can also do it by using the random number. Like we can create a pd.data frame using np.random.rdn. So what will this random number will do? It will create a matrix, okay, with 5 rows and 5 columns, and we are putting it into a kind of a data frame. So we can also use pd.data frame. We can use concatenate method for combining the series, but for if you want, we can also use the data frame, pd.data frame, for if we want to use creating data frame from a matrix. So we can do that. So we can see here a data frame is created and these numbers are being randomly generated as we have used this IDN method. So we have 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, so these are the indexes for the rows and columns respectively. Then what we can do, we can give the labels to rows and column, because by default there are no labels when we create a data frame. It's just like 0, 1, 2, 3, 4 and 0, 1, 2, 3, 4. So how we can give the labels to the rows and column? So for rows, if you want to give the name to your rows, so you have to use the parameter called as index. Index is equal to first row, second row, third row, fourth row, and fifth row. But if you want to give the name to your columns, you have to use this parameter columns inside this pd.data frame. Okay, so I've used the same code here, np.random generation, np.random generation, comma, but I want labels in my code. So I have used index for the labeling the rows, and column parameter for labeling the columns. Okay, so let's see now. Now we see we have got the labels: first row, second row, third row, fourth row, fifth row. So we can see here first row, second row, third row, fourth row, fifth row. And similar way, first column, second column, third column, fourth column, and fifth column. So this way you can provide the row names and the column names accordingly. Now we can also access individual series in the data frame. Now if I want to get this column, this first column, okay, so I can just specify this, like the data frame name inside the square brackets. You can provide the column name. Okay, so I have provided second column, so I will get the second column all the values. You can see 1.51, 0.18. So all these values are being printed to as an output. Okay, the next thing is we can also access the rows. Okay, we can also access the rows of a data frame using the lock method. Now please remember, when you are using the lock method, you have to provide the name of your index, the name of your index. So it is fourth row here, so you have to specify the fourth row, and then you can run this code. So you will get the the fourth row values. What are the fourth rows values? So fourth rows values are these values: 1.41, 1.22, 0.44. So all these values will be displayed of all the columns. But if you want to get the value from a particular row using an iloc method, then you have to specify the index value. Okay, and by default the index value is 0, 1, 2, 3, 4. So please remember, iloc is for index value. To get the row values, you have to provide the index of that particular row using the iloc. Just remember, I stands for index. And if you provide the lock method, then lock method you have to provide the name of the name of the index. Okay, instead of the number. So if here we have provided iloc2, so iloc2 means 0, 1, 2 is going to display the third row. So we can see here, it's going to display the third row. It's going to display the third row in this way. Now we can also get like values which we want, like I want the fourth row and first row, second column and third column. So if I run this, so it's going to give me these values. Okay. We can also do some kind of mathematical operations, whether it's logical or whether it's a kind of additional subtractions. We can do that on the data frame. Now let's assume that I have this data frame, random df underscore new. Now if I do greater than equal to 0, so what's going to happen? It's going to check for each and every value, all the elements for each column and for each row, all the elements of this data frame, and it's going to check that which values are greater than 0, then it shows true. If it is not greater than 0, it's going to give us a false. So we can do it in this way. So it's basically a kind of element wise operation. If you just put the data frame greater than 0 or less than 0, then based upon the element wise comparison, it's going to display the results in a Boolean format. Next is we can also add a column to the data frame. How we can add a column? You have to specify the data frame name. You have to specify the name of the new column which you want to create. I want to create a new column with the name sixth column. Okay. And then you can provide that what are the values you want to put inside it. So I provided this value that I want these values inside it. Okay. And then when I run this one, so you can see here the sixth column is being added. Sixth column is being added here with all the values. Okay. So this way we can add a column inside it. Now, the next thing is we can also remove a column. So for removing a column or rows, we use this drop method. We use this drop method. So when we do random df underscore new dot drop first column, axis is equal to 1, in place is equal to true. Okay. So when I say in place is equal to true, which means that whatever changes, whatever the data frame is being created after dropping first column, that will be saved. Your new data set will be saved, and your new data set should not contain the first column. If you don't use this in place is equal to true, what will happen? You have dropped it, but that the new data frame which was created, that will not be saved. Okay, the original will remain the same. So this way, we save our operation. Okay, so we can see here we have dropped the first column. So first column is being dropped here. So we have second, third, fourth, fifth, and sixth column. The other thing is we can also drop the second row. So if I drop the second row, so you can see the second row is also being dropped. So we can drop the rows also. We have seen how we can drop the column. We can drop the columns also. But always remember one more thing, that when you are dropping the columns, or when you are deleting any column, you have to use axis is equal to 1. But when you are dropping any rows or deleting any rows, then you have to use axis is equal to 0. Okay, so this way we can delete a row and a column in the Pandas data frame. We can reset the index. We can reset the index in data frame. So you can see here the index is being reset here, 0, 1, 2, 3. Okay, the old index is not being used. We can assign new names to the index. Like I want to specify this name as an index, so I can do that. So this new name is being provided as an index. Okay, then other thing is like we can set index to new name. Okay, so what happened is like we created a new column, new name, and we want this new name column values as the index. So now you can see this is the new name as the index, this is the row. Okay, so this is how we can do the we can do the setting of the resetting of the index. Okay. Now the next thing which we are going to talk about is the data frames. Now when we are talking about data frames, we know that data frame is a kind of a tabular data. Okay, it contains rows and columns. It is just similar like a SQL table, but the but and that is the main reason why some of the operations which are in SQL, like concatenation, join, merging, all those kind of operations, okay, are being supported by Pandas also, because data frames and SQL table are quite similar. It's similar. It's just a kind of a CSV or a kind of a tabular data. So let's see about concatenate method. Okay. So what is concatenation method? Concatenation method is like combining two data frames. So I have created here two data frames, data frame 1, data frame 2. I have used DF. DF is for the abbreviation for data frame. Okay. So let me run this one. Let's see the data frame. So this is the data frame which has the columns customer, category, important, sales, and it has these values. Okay. Similar way, we have data frame 2. So data frame 2 has customer, color, distance, sales. Okay. Now, if I want to concatenate df1 and df2, okay, then what we are going to do, we are an x is equal to 0, which means it will be a kind of a row-wise addition. X is equal to 0 means row-wise addition. Sort is equal to false. So what will happen? These all will be added together, 0, 1, 2, 3, 4, 5, 6, 7, in a kind of a row wise. 0, 1, 2, 3, 4, 5, 6, 7, kind of a row wise. And this is going to give us a new data frame. Okay, we use the pd.concatenate. You have to provide pd.concatenate, and inside the bracket the two data frames which you want to merge. So I'm merging df1 and df2. I'm doing the concatenation on df1 and df2. X is equal to 0, sort is equal to false. I have used the sorting is equal to false here. Okay, then I'm going to do this pd.concatenate df1 df2, but I'm doing the sorting operation here. The sorting operation here, when I'm doing, so it's going to sort it in a proper manner. Like first it will be an alphabet with starting with C, then the color, then the digits, then again the digits, and then again the digits, and then the digits. Okay, so this way it's been sorted out. Okay, now the next thing is, if I want to do a kind of an addition by column wise, so I have to use x is equal to 1. Okay, so here the concatenation is happening by column wise. So you can see here, so this is how the addition happens with the help of the column wise. Okay, so when we are doing column wise, so then you have more, you can see more columns: customer, category, important, sales, customer, color, distance, sales. So we have just put the things in a you can say that one table is there, and then one table is put on the right side, and then they are joined together, column wise joining. Okay, so this way we can perform the concatenation. So concatenation, what we have seen, we can use the pd.concatenate method, and we can do the concatenation row wise, and we can do the concatenation column wise also. Okay, now the next thing is which we are going to talk about is merging and joining. Okay, so merging and joining is just similar like uh, just a similar kind of an operation that we have learned in SQL. So let me first the two data frames which we used, df1 and df2. So this is the data frame 1. We just saw this one, the same table I'm going to use, df1 and df2. Now here in the period, we have the outer merge. Okay, merging is a kind of outer merge is a merging can be of different types. It can be outer merge, inner merge, right merge, and left merge. So outer merge is basically the union. Okay, union of all the rows and columns of left and right data frames with, and it puts nan where there is no matches. Okay, so let's see this. When I run this one, so what will happen, it's going to create a data frame where all the values of table 1, data frame 1, and data frame 2 will be included, including and how we are doing it on customer. We are doing it on the customer, this particular column. We are doing it on this particular feature. We are doing it. Okay, so it's going to include all the values, all the customers from this one, from the df1 and df2. Okay, you can see 101, 102, and the sum of the values, okay, where for which there are no values provided. Okay, so then it is replaces by nan is basically not a number, which means a kind of a null values. Next thing is we can do the inner. Inner is basically the intersection. So what is going to do, it's going to take out the common values which is being present in the two data frames. So let me do this. And how we are doing it, we are doing it on the feature customer. So let me run this. So when I run this, so it's going to take out only the customers which are common here. So what are the common customers? 101, 102 is not there, 103 and 104, 105 and 102 are only present in customer 2 and customer 1, sorry, customer of data frame 2 and 1 respectively. So here it's going to give us these values of this one. Okay. The next thing is that we can do the right merge also. So basically when we are doing the right merge, what happens is that the data frame which is present on the right side, which is the df2, okay, so all the values from df2 will be included, but only the common values between df1 and df2 will be included. So that is how this right join is happening here. So what are the customers which is present in df2? 101, 1, 3, 4, 5. Okay, so we have 1, 3, 4, 5. Okay, and the common part is removed. Okay, so this is how we can do the right merge. Similar way on the left merge. Okay, left merge, what we are doing, it keep all the rows of the left data frame and the common part. Okay, the common intersection part. So this is the left, so it's keeping all the things which is present in the df1. Okay, df1 is the left data frame. Similar way, let's create two new data frames, df3 and df4. Let's display them. Yeah, but now we are going to look into joins. Okay, so what is the difference between joins and merging? So basically the way both are same, but in the case of merge, okay, in the case of merge, what how we are doing it, we are doing with the help of this column names. Okay, but in the case of joining, we are doing it on the basis of index values. We are doing it on the basis of index values. So join behaves basically just like a merge, except instead of using the values of one of the column to combine data frames, it uses the index labels. Index label means I0, I2, I3. Okay, so it's just the same kind of doing it. So df3 dot join df4 how is equal to write. Okay, so when I run this one, so it is going to keep the, we are doing a kind of a right join on df3 and df4. Okay, so df4 df3, how many columns are there? Three columns, I0, 1, 2 and 0, 2, 3. So 0, 2, 3 will be retained, all the values of 0, because df4 is on the right side, so all the values of the df4 will be retained. Okay, so you can see here all the values of df2 is being retained. Okay, and the what are the common values which is being present, they are being added here, like q1 q2 values of df3 is being added here. So this way, just remember, if somebody asks you that what is the difference between um, merge and join, so you can say that in pandas, merge and joins are a similar operation, but the difference is that when we talk about join, we are the pandas joins the two tables using the indexes, but when we talk about merge operation, pandas joins the two data frame using merge operation by using the column names. Okay, now there are some built-in methods in pandas. So we will see, let's print the data frame. This is the data frame. Yes, so we can see here customer is there, color is there, distance and sales. These are the some of the column names which we have. Now, if I want to find it out that how many unique values are there in this color, okay, so I can just use this unique method. So it's going to give us that, okay, there are three unique values, yellow, green and blue. If I want to find it out how many unique values are there, I can use this n unique method. I will run this one. So it has three unique values. Okay, now if I want to find it out the unique values inside this color and how many times they are repeating, what is their value count. Okay, so then for that purpose I use this value count. Please remember, this value count is one of the most important pandas method. It is one of the most important pandas method. So if I run this one, so it's going to be giving me that green appears two times, yellow appears one, blue appears one time. Okay, why this is important? Because when you are given any data and you have a very huge data set, so you can just say that df2, that particular column name, and then you do value counts, then you will get the details. You're working on a classification problem where you have to find out how many people have diabetes or not. Okay, then you can check with that column. What is the, how many people have diabetes, how many people don't have diabetes, or what is the gender ratio. Okay, so that's where there is a kind of a categorical feature. This value count method is very much important. It gives you the count of each and every value which is present inside that particular categorical column. Next thing is we can perform the mean. We can do this df2.mean. So what will happen when you run this one? So it's going to automatically, because we know that mean is a mathematical operations. And in this, all these features, we have only color, distance, and sales as a numerical columns, which has numerical values inside it. But color is a categorical. So by default, when you do any kind of a mean, median, or you can say standard deviation, variance, so it is going to pick up those columns which has numerical values. So this way, when you do this, where I was, yes. So df.mean, so it's going to give the mean of the customers column, distance, and sales. If you want to find it out, create a new data frame using any kind of a logical operator. Like let's assume I want to create a data frame. Okay, and that data frame should contain a customer column. Okay, whose value should not be 105, or whose color should not be equal to green. Okay, so this way we can create a kind of a new data frame from an already existing data frame. So let me run this, and we see we got one data frame with only one row and four columns, which has value this one. Okay, we can also find out the sum. If I want the sum of all the sales, if I want the sum of all the sales, mean of all the distances, all those things by using the df, by using the name of the data frame, then the column name, and then the sum method. Okay, similar way we can find out the minimum value, maximum value, and all those things of a particular numerical column. This way we can get it. So we can also get the profit. So here we have the sales. So I just use the simple formula. Just say 50% markup is there. So profit is equal to return s multiplied by 0.5. Now I want to use this method to calculate the profit on the sales. So I will provide the data frame name, that particular column name, which is sales dot apply, and then the profit method. So it's going to give me the profit for each and every sales value. For each and every sales value, like how much is the profit for this one, this particular value, this particular value, and this particular value. Okay, so this way we will get the profit. Okay, we can also get the we can also check the length. Okay, length is like something like if we want to check the color. Okay, that color, and then apply length. So it's going to give us that what is the length of these values. Okay, so you can see the yellow has a length of 6. This has a length of 5 and 4. So that is why it is giving us the length of the 6, 5, 5, and 4. Next is that we can also use the apply map to get the profit. We can apply that and we get these things accordingly. Then we can also find out the sum. We can find out the sum of the entire. We can also use the similar dot sum method, but we can also apply it like this way by using the apply method. So basically we can say that if you want to use any customized method inside the pandas, you can use the apply method, dot apply method. Okay, so I will run this one and it's going to give me like this. And then you can see here all the values. Now, if I want, this was the data frame which we have, which we created. If I want to delete any column, like I suppose I want to delete this color, I can just use this del keyword, df2, and then specify the column name, and then this particular column will be deleted. So you can see here the color is being deleted here. We can also get the df.index. So we can sort values. We can also sort the values by distance. If I want to sort the values in the data frame using distance, we can use the sort values method. Parameter by is equal to distance. Okay, so what will happen? This data frame will be sorted by using the distance value. So from lower value to the higher value. Now, if some series has multiple of the same values, we can group them, all the unique entries. This is what I'm talking about, is the group by method. Okay, so let me first create a dictionary. Okay, and then I will create a kind of a data frame. So I have used this pd.data frame from this dictionary. Okay, so this is the data frame. It has customer 1, customer 2, product 1, product 2, and the customer names, and then product. Okay, then we have the purchase. So each row is representing a purchase. Okay, Now, if I want to group by using customer, we can just use this group by method. So I will just use group by df4.group by customer. So what will happen? The data will be grouped together by customer. Okay. Now, if I want to find it out, the standard deviation for each customer for all the product 1 by 2. So I can use this standard deviation. So it is going to give for all the customers because we have grouped by customer. So all the customers and the standard deviation of all the products for each customers. Similar way, if I want to find out the median for each customers, like what is the median of the product one bought by customer one, product two bought by customer two. So like this way, we can do this thing by using the group data. We can group the data accordingly as per. Sometimes we get a data based upon different countries. Okay, we have sales for different countries, or we have the employees of different countries, and they have their salaries, age, and their years of experience. And if we want to filter out based upon a particular country, that we want to focus only on, let's say, Netherlands. Okay, so then that way we can filter out the data based upon Netherlands by using a group by, and then we can perform these operations to get the more insights on data. The next thing is, we already know that that just similar to NumPy, pandas can also be used. Like, we can, whatever data frame which we have created here, that data frame can be stored in your local machine. Okay, that can be converted into a kind of a CSV or a Excel file. So here what I'm doing is that I have created this data frame 4. I'm just trying to store it by using the 2._CSV. So this will be df8.csv. So what will happen when I run this? Okay, so automatically in my this folder, okay, this Python tutorial folder, this df4 will be created. 1 second. There it is. Yes. So df8.csv is created. You can see here df.csv is being created here. Okay. So this is basically inside your C folder. Users. Mine is Saurav. C users Saurav. And inside that I have created this Python folder because we have installed Anaconda in the C path. Okay. And there you can find this this folder. Okay. Similar way, we can read also. When we want to read any data frame, we just do pd.read csv df8.csv. Okay, so it's going to read the data frame for us. If we want to store any data frame in the form of an Excel, so we will use this method to Excel. Okay, so it will be df8.excel. So it will be stored in this format. So we can see here df8.excel is being saved. Now, if we run this, and we can read this as by using this pd.read Excel. When we talk about reading the values, there are a lot of other methods like read CSV, read Excel, read JSON. Okay, so we can read so many different formats of data. So that's what the advantage of using NumPy. So this was all about NumPy. This was all about pandas. Yeah.